For years, the problem kept growing faster than anyone could stop it. Across Texas, farmers woke up to fields torn apart overnight. Wetlands were churned into mud, fences collapsed, native plants vanished, rivers carried bacteria and sediment downstream. What caused all of it were animals that most people underestimated for far too long. Feral hogs. Wild pigs spread across Texas at a pace unmatched by almost any other invasive mammal in North America. By the early 2000s, their numbers had reached into the millions. Some estimates placed the population at over 2 million animals, with no sign of slowing down. Texas was losing control. Feral hogs are not native to the region. They descend from domestic pigs brought by European settlers centuries ago and from Eurasian wild boar introduced later for hunting. Over generations, these animals escaped captivity, interbred, and adapted rapidly. Texas provided ideal conditions: mild winters, abundant food, vast land, and limited natural predators. The result was explosive growth. A single female hog can reproduce at 6 months old. She can give birth to 2 litters per year, each containing up to 12 piglets. Under good conditions, a population can double in less than 12 months. Traditional wildlife management strategies were never designed to deal with reproduction on that scale. The ecological damage mounted quickly. Hogs root aggressively, using their snouts to dig deep into the soil. This destroys native vegetation, uproots seedlings, and exposes soil to erosion. Ground-nesting birds lose eggs. Reptiles and amphibians lose shelter. Wetlands collapse as plants are uprooted and water becomes cloudy and polluted. Agriculture took a direct hit. Corn, rice, wheat, peanuts, and sorghum fields were devastated. Hogs consumed feed meant for livestock and attacked young calves, lambs, and goats. Fences and irrigation systems were damaged repeatedly. By conservative estimates, feral hogs caused hundreds of millions of dollars in damage every year in Texas alone. At first, the response was reactive. Landowners hunted hogs whenever they could. Weekend hunts became common. Some areas promoted hog hunting as sport. Helicopter hunts made headlines. Despite constant effort, hog numbers kept climbing. Removing a few animals here and there did nothing against a species that reproduced faster than it could be killed. Texas faced a critical realization. Hunting alone was not only ineffective, it sometimes made the problem worse. Hogs are intelligent and highly social animals. They live in groups called sounders, usually made up of females and their young. When hunters removed 1 or 2 hogs from a sounder, the survivors learned quickly. They became nocturnal, avoided open areas, and spread into new territories. The pressure fragmented populations instead of reducing them. The state needed a new approach. Texas began treating feral hogs not as game, but as invasive pests. This policy shift mattered. Restrictions were lifted. There were no seasons, no bag limits, and no licensing requirements on private land. Hogs could be removed year-round by almost any legal method, but legal freedom alone was not enough. Biologists and wildlife managers focused on how hogs actually behave. The key insight was simple. To reduce populations, entire sounders had to be removed at once. Partial removal only guaranteed faster reproduction later. This led to widespread adoption of large corral traps. Unlike small box traps that captured 1 or 2 animals, corral traps were designed to capture entire groups. Circular or polygonal enclosures were baited and monitored with cameras. Remote triggered gates allowed operators to wait until all animals had entered before closing the trap. This was a turning point. Instead of removing a few hogs at a time, landowners could eliminate 10, 20, or even more in a single operation. Population growth slowed noticeably in areas where corral trapping was used consistently. Technology amplified the effort. Motion-activated cameras tracked hog movement patterns. GPS data identified travel corridors and feeding zones. Traps were placed strategically rather than randomly. Control efforts became targeted, not reactive. Then came aerial removal. Texas authorized and expanded helicopter-based hog control programs, particularly on large ranches and inaccessible terrain. From the air, entire sounders could be located and removed quickly. While controversial, aerial control proved one of the most effective tools for rapid population reduction. Crucially, Texas did not rely on any single method. Trapping, aerial removal, night shooting, fencing, and habitat management were combined depending on local conditions. Sensitive ecosystems received priority protection. Agricultural zones focused on crop loss prevention. Flexibility was essential because hog behavior varied across regions. Coordination became another key factor. Hogs do not respect property boundaries. Removing hogs on one ranch meant little if neighboring land did nothing. Texas encouraged regional cooperation. Landowners shared data, synchronized trapping schedules, and coordinated removal efforts to prevent reinvasion. This collective approach marked a major shift. Previously, hog control was an individual burden. Now, it became a shared responsibility. Counties, conservation districts, and private landowners began working together. Education played a critical role as well. For years, hogs had been illegally transported and released to establish hunting opportunities. This practice dramatically accelerated their spread. Texas cracked down on illegal transport, increased penalties, and launched public awareness campaigns, explaining that moving hogs created long-term damage for everyone. Research institutions contributed heavily. Universities studied hog reproduction, movement, and behavior. Scientists evaluated toxicants, fertility control, and improved trap designs. While no perfect solution emerged, incremental improvements increased efficiency across the board. One of the most important lessons involved timing. Removing hogs before breeding seasons had a disproportionate impact. Targeting female-led sounders reduced future population growth far more effectively than killing solitary males. Protecting key habitats early prevented long-term ecological collapse even when eradication was impossible. Results were not instant, but over time, they became measurable. In regions with sustained coordinated control, hog numbers stabilized or declined, crop losses decreased, native vegetation began recovering, wetlands showed improved water quality, ground nesting birds returned to some areas. Texas had not eliminated feral hogs. That goal was never realistic. Instead, the state reframed success. The objective became containment, reduction, and damage control. This required continuous pressure, not temporary campaigns. When control efforts paused, hog populations rebounded quickly. The war against feral hogs turned into a long-term management challenge. Texas also learned from its failures. Bounty programs created perverse incentives. Short-term hunting pressure failed. Relocation worsened spread. Ignoring reproduction doomed early efforts. Every mistake reinforced the same lesson: invasive species management demands realism. Feral hogs succeeded because they exploited gaps in policy, coordination, and biology. Texas responded by closing those gaps systematically. The approach was not dramatic. It was persistent. Traps were checked daily. Data was reviewed constantly. Cooperation was maintained year after year. No single moment marked victory. Progress came through accumulation. The landscape is still under pressure. Feral hogs remain a serious problem in Texas, but the state is no longer reacting blindly. It understands the enemy. It understands the limits of control, and it understands that invasive species are not defeated through optimism, but through sustained, adaptive management. Texas did not win the war against feral hogs, but it learned how to fight it intelligently. And in doing so, it created a model for how large-scale ecological crises can be managed, not with one solution, but with many small, relentless ones working together over time.